In last two lectures we have discussed basics of control charts and the various types of control charts we have discussed. Now in today's session we'll move on with X bar and R chart. I think in last lecture as well you have solved one numerical related to X bar and R chart. So few things related to X bar R chart we'll be discussing today, and then we'll go for a numerical. So we are discussing variable charts. No need to worry about the names whatever I have taken today. I just randomly wanted to contact you whether you are solved, and I think again for this sir has told regarding your assignments on your Google Classroom. So many of you have not attempted that. So for some assignments though deadline was not present, so it was in favor of you. So you should take the advantage of it and immediately solve the assignments as soon as possible. Okay, we'll start with now. So control chart we have started. So what does control chart do or help us? So control chart allows a company to perform or check its performance over time. So how to check it or how to check the performance for any company? For that, we have to combine few things. That is, first we require is the data. That is performance data we have to collect it. So combination of this data we require. And then from that data we have to analyze few things. So what analysis we can do is we can find out the average, range and standard deviation. So most probably you know all these three factors in case of statistics, but how to interpret it we will be discussing today. So all this following process provides us the result of the company. It may be in terms of profit, it may be in terms of product quality, or it may be in terms of we can say the performance. So for this, control charts will be very much helpful. So for that we require, so to draw a control chart, firstly we require the data. So what does this data will do? The data used in the control charts will be used for finding out the X bar and R charts. So for that we require some of the samples from a given population. So what does this population, what does this sample mean? So for example, if we have a company related with suppose Gillette blades, so for that they will be collecting some of the data in the sense they will be we can consider suppose they are measuring the thickness of the blade or some of the dimensions of this blade for some specific given period or a time. So in that case, suppose 15 hours were separately noted down, so each of 1 hour, so every hour some of the samples were checked, samples in the sense the blades were checked. So in each hour some of the samples means the subgroups. This will be called as the subgroups from the total population, and each subgroup will have some of the data, suppose measured number of times as in this is shown as 5. So we represent this as n. So to understand it clearly, if we tabulate all this data, we'll get it as it is. So you can check this table. So table for a Gillette example, that is this hour will represent the samples subgroups. So starting from 1 to 15 hours total subgroups, and each subgroup will consist of 5 measurements. So first, second, third, fourth, and fifth. So 5 times measurement has been done. And every time in each hour, you'll be getting some sort of data. So where to write it? So we can tabulate it. So any worker who is working in the razor blade company, maybe example given as shown in the slide as Gillette. So what he will do is he will just check this number of samples, 5 samples or 5 times measurement for each single sample he may take. So all this will be tabulated, maybe noted down on the sheet. Maybe you can say check sheet or maybe you can say a table. So all this data is now tabulated. Now what to do of this data? So how you will interpret it? So how you will get the knowledge from this data? Just collecting the data will not do the need. So what you have to do is you have to analyze this data. So whether the sizes of the blade, whether the factor, suppose thickness you are checking for a blade, so whether it is within the limit or not. So our manufactured product is of a good quality. Final aim is of whether it is of good quality. So how we can say a good quality product? For that, some of the factors are decided, some of the factors are standardized. So within standardized in the sense, some values are having some sort of limits. So since we have discussed limit with tolerance, so some sort of tolerance is to be provided for that. So one will be upper limit, one will be lower limit. So two limits and within which the data should lie. So all the data which is collected in this table should be within the limit. Now, how to analyze this? We have to just do few of the calculations related to the data. So first will be, so we have to find out the mean of the values. So 5 samples were there, so its mean we can find out. So for that, a simple formula we can use, that is summation of all the values divided by number of values as n. Then second factor we have to go for calculation is r. So we have to find out the range, and next we have to find out the x bar, means the mean of that. So x bar can be found out with the help of this formula, that is summation of all the samples or population divided by number of samples. And range can be found out with the help of a very simple formula, that is maximum of all the samples, the value which is maximum subtracted by minimum out of all the same samples. So what we will get is a range. Next we can go for the chart data, that is we have to go for calculating the mean of mean, that is x double bar, and next we have to go for mean of range, that is r bar. So same thing, so summation of all these mean values divided by total number of subgroups, and same thing with range values, summation of all the range values divided by total number of the subgroups. So this simple four formulas we will be using, very much simple formulas for just analyzing the data for calculation purpose. Now suppose same data we have. Now what we have done in from this data, you can see that for a single sample, the values we are having, suppose for each hour, first measurement was this. So likewise second, third, fourth, and fifth. So total n samples are 5. N measurements are 5, and likewise for each hour we have got some data. You can just check it. So all this data, what we have to do is first we have to find out the x or mean value. Mean of all this we have to form, or you have to draw it, or you have to write it, or we can say you have to tabulate it in a table of mean of each hour is shown over here. Next thing we have is range. Now how to calculate the range? Out of all this, for each hour, what will be the maximum value and what is the minimum value? You have to check it first. Suppose 27.0627 is the maximum value, and suppose 0.0624 is the minimum value. So x max minus x minimum will be this. So subtraction of this, you will get it as range. So this R. So same four formulas we are using. Next thing we have is, likewise, you have to go for each hour, each subgroup, and you have to form, or you have to get this. Next formula was, you have to find out mean of mean, that is X double bar, mean of mean X double bar. So for that, we have to take mean value of whatever sample mean we have found out for each subgroup. Next thing, we have to find out the mean of range. We have this range values, mean of range values, that is R. Now again, we have got few observations we can say over here, and then we have done some sort of calculation by finding out the mean value, by finding out the range value. Now what to do with this data? How you will come to know whether some sort of calculation, some sort of observations we have taken, whether it is helpful or not, the data which we have collected or the data which we have calculated is of what use. So to identify this, we have to go for drawing the charts. You have to represent it graphically. So this graphical representation, we call it as X bar and R bar chart. So this sort of diagram, we call it as control charts, and whenever this red line indicates X double bar value, it is called as X bar chart, and whenever this red line indicates in second graph R bar, we'll be calling this as R control chart. Now based on this, so this following points we have noted. Now how to draw X bar chart? We have got one table. We have found out mean value of each hour sample. So all that 15 values we have plotted. So we will take on x-axis as subgroup, and on y-axis we will have measurement. Same case with the R chart. We'll be using the range calculation on y-axis, and on x-axis we have subgroup sizes. That is, in our case, is related with the hours. And then we have to divide this as per our appropriate dimensions. So it is no need, or it is not mandatory that you should always take the values from the origin as 0. Sometimes you can start it as per our feasibility. So for that, you have to analyze the data and then you can go with it. So what does this points represent? It is nothing but the data which is calculated from the x values. This line represent the X double bar. Again, this is the range values, and this is nothing but the R bar values. Now we have drawn some sort of chart. Now how to analyze it, how to interpret it? So in your final examination, this much will be sufficient for you. Just calculate, observe the data, form a table, calculate the values, tabulate it, and just draw the chart. Now drawing the chart, you can go by number of methods. Either you can use some sort of tool. Tool may be related to your Excel, or maybe some of the softwares, we can say design expert software is there, or either we can say Minitab software is there. So all the softwares, statistical softwares, intentionally I will call this, because this will provide us the statistical data with graphical representations. So all these tools we can use, or either what we have is, we can use our pen pencil and just use the representation notebook or notepad. In case while you are, or you will be solving numericals in your examination, you will be using notebook and pen only, since even examples will be very much simple. But as a quality engineer when you will pass out and when you will do all this work. So data will be too much. So not as the numericals in case of your exams. So target is few of the points we have got as per our collected data. Now how to interpret it? Just we have noted those points, we have pointed those points and we have just connected it with the help of lines. Now how to note this or how to interpret it? So before starting with that, upper and lower control limits are represented by three standard deviations because red line what I was talking about was the mean line, whatever we have calculated, maybe for range, maybe for X bar. So from that mean, from the above and below, we have three total sigmas, three sigma variation from towards the upward side and three sigma variation toward the lower side. Variation in the sense standard deviation I'm talking. So instead of calculating standard deviation for all samples, we will use few formulas for this because to represent those, we want some sort of limits. So how to calculate these limits? So X bar upper control limit and X bar chart lower control limits. So these formulas are very much important. Again, it is too simple. What you would remember is A2. Simply A2 is added over here. So X bar upper control limit and lower control limit can be found out with this formula, that is X double bar. You can take a snapshot of the slide because we'll be solving few numerical in the same lecture now. So X double bar plus A2 into R bar. Likewise, lower control limit will be represented as X double bar minus A2 into R bar. So whereas how you can get the A2 value, you can get it from this table. So this is the standard table, you can get it from the books. Again, same case for drawing the R chart, we required two limits again. That is upper control limit for R chart and upper control limit for, lower control limit for the R chart. But while calculating lower and upper control limits, we are going to use some factors. That is D4 and D3 factor, and same can be calculated from this table. So A2 factor will be useful for calculating the limits of X chart, and D3 and D4 will be very much helpful in case of R chart. So following table either will be provided while solving the numericals in examination, or either the direct values of A2 and D3, D4 will be provided to you in the numerical itself. So no need to worry about the standard values or of this table. So it will be directly provided. And how to select this if table is provided? So it will base on the number of samples. So in this case, what we have to use the n value, that is 5. So sample size is 5, or sometimes it may be 2, 3, 4, likewise till 15. Again, more than 15 we have different tables. So likewise, this table will be very much helpful. So this was the calculation part related to your limits of X bar and R chart. So considering our same example, by substituting the values, you may get some sort of values. As in this case, we have got, suppose, upper control limit indicated as green line in X bar chart as 0.0627 and lower control limit as 0. So upper control limit and lower control limit. So we'll be representing this. So important about this control chart is x-axis and y-axis. Y-axis will represent the measurement observations or mean values, and x-axis will represent the samples or subgroups we can say. And with that, three lines indicating the three sigma above and below of the red line will be your limits, upper and lower. And upper and lower control will be using specifically around 3 sigma variation. So this was all about the chart, how to collect the data, collaborate it, collectively analyze it, and calculate the values based on the samples. Now, after drawing this, how to consider or how to interpret it? So to analyze the control chart, it is important to remember the data which is represented. That is same case what I was talking about. That is 6 standard deviation. This one, 3 above the mean line and 3 below the mean line. And again, this 3 sigma is divided into 3 sections, A, B, and C. So what is this A, B, and C? Each alphabet represents a single sigma, that is 1 sigma, 2 sigma, and 3 sigma variation. So you can check the same diagram. Suppose this is a R chart and the different zones of sigma are represented by some sort of color. So center line indicates the mean value that we was talking in earlier lecture as central tendency. And from this central tendency, we have some sky blue pattern of color over here as 1 sigma level, and it is represented as C. So zone A, I think it might be visible to you. This will be zone A for upper control limit above the mean line and zone A for lower control limit below the mean line. Same case as zone B, both above and below, and again same case which is zone C. So what you can remember is zone C is very much closer to the mean line, whereas zone A is away from the mean line, and combination of this will provide us the 3 sigma variation. Now how to interpret again, same thing I'm talking. Now we have got some sort of pattern for this numerical, or you will get again number of patterns for same type of sum of observed data, whatever data you will collect it. So interpret the data. First, we have to look it at the R chart. Always for any data which is collected, when we are talking about variable chart, we'll be calculating X mean and R mean, and then we'll be plotting X bar and R chart. But from both chart, first we have to look at the R bar chart, that is R chart. And if R chart is okay, then we have to go for X bar chart. So variation, if it is great for R chart, then no need to go for X bar chart. But if the R bar chart represents some sort of variation, and then that variation can be checked with the help of X bar. So always first we have to go for checking the R chart. Now how to interpret it, few of the points are shown over here. So whenever, or what we can say, when is our process out of control? So first thing is, if any one point falls out of the 3 sigma control limits. So one example is shown over here, this one, that is if a single point may be positive 3 sigma value or negative 3 sigma value, if either any one single point falls out of the limits, we can say that our process is out of control. Next thing is, if 2 out of 3, any 3 successive points, if we have 3 successive points, suppose 1, 2, and 3. So out of these 3 successive points, any 2 falls in the A zone, zone A, maybe below this or maybe above this. So that time also we can say that our process is out of control. Third thing is, if 4 out of these 4 points, out of any 5 successive points fall in or beyond the zone B of the same side. So never any continuous 4 points should fall in any one of the zone. So that time also we can say some sort of process defect is there or some sort of problem is there in the process. So that is process is out of control. Next thing is if 8 successive points fall in or beyond the zone C of the same side. So either any 8 values are beyond the mean value, maybe above or below. That time also we can say some sort of error is there in our process and our process is out of control. So this thing you have to remember. So standard chart will look like this. So sources of variation already we discussed, but timing you can just read out. So common causes of variation, unavoidable causes for this. That is random causes that we cannot identify is unavoidable and slightly different. That is it may be in the case of diameter or weight. Already we have discussed this. And again, assignable causes of variation may be or can be identified and eliminated. So this may be poor employee training or worn out tool, or maybe we can say machine needs the repairment. So if these factors come into picture, that time only we can get the variation in the. And if you look at these charts, so why not we are getting all the points along this line? Can anyone try to elaborate this? You can post it. Why not we are getting for number of observations? Why our observations are varying? Any reason behind this? One specific topic we have discussed for this in our last lecture. So can you just post it maybe in the chat box? One good example by Prathamesh is error. And another reason for this? Any other reason? Again, one specific sentence we have mentioned for this. Why? Tolerances to accommodate for this we are using. Any other? Anyone? It is possible to make perfect dimension product. That is, that's why we are discussing the term interchangeability. So no component is identical. So there are number of reasons and same reasons which we were discussing. That is nothing but variation. That's why we are drawing these charts, variation control charts. So what type of variation we can have? Either it may be small variation or maybe related with the large variation. So small variation may be dispersion of data will be just nearer or closer to your mean line. Suppose this is the mean line and this bell-shaped curve will be very steep slope. But sometimes if your variation is too large, so this slope may enlarge and the variation will be large. So control charts, the point out of control and control limits, that is 3 sigma control limits and 6 sigma control limits. So don't worry about the numerical values which are mentioned over here because this point will be discussing in our process capability, that is parts per million. So how many parts per million lies within the 3 sigma and 6 sigma, that will be discussing with our specification limit, that is USL and LSL, which is the case of process capability. So time being, so mean chart tracks the central tendency, whereas R chart tracks the spread of the distribution. So instead of moving for central tendency, our target is to estimate the observed variation. So that variation always, if there is shift in the X bar, though R chart is perfect, so there may be the shift in the X bar chart, or either some of the points may lie. This is a good example to monitor these two charts. So because what I want to say is, if R chart we are first observing, dimensions are okay if we collect this, and though we cannot say our observed values or processes within the control, because for that you have to again check your X bar chart. So X bar chart may vary in this fashion, or sometimes X bar is okay. So in that case, our spread may be varying. So though central tendency is okay, our spread may vary. So that time also we can say that process is out of control. So I think you can solve one simple numerical based on this. You can note down this value and just you can post it the mean value and R bar value for this given example. I will wait for a few minutes. Just try to calculate mean for respective time. Don't worry or don't get confused, because observation, instead of showing horizontally, they are shown as vertically, and time is shown horizontally. So average will not be over here, but average of respective hour, that is time, you have to consider. A quality control inspector, you can take your time for 5 to 10 minutes and just post the values of X bar and R bar, and with that the X double bar values. A quality inspector at Coco Fizz soft drink company has taken 3 samples, and each sample with 4 observations. Each of the volume of bottles were filled. And if the standard deviation of the bottle operation is 0.2 ounce, so use this data to develop control chart with the limits of 3 standard deviation. Okay, time 1 values, mean of time 1 is okay. Uh, Post the value of range for that time 1. What will be the range? Maximum is 16 and minimum is 15.8. Again, in case of time 2, maximum value is 16.1 and minimum is 15.8. Likewise for time 3. Side by side, you can check the values. Though you have posted the values, all are correct. So sample means will be 15.875 for first. Second time hour is 15.975. For third, it will be 15.9. So difference of 16 and 15.5, you will get it as now. Whenever standard deviation is directly provided, one change is there in this numerical. You can just try to concentrate over here. Whenever standard deviation is provided, that is 0.2 in this case, so you can use this formula for calculating the mean value. That is, standard mean for this will be sigma by under root of n. So this formula you can represent for sample mean. This is the most important difference over here. Other things will remain as it is. And whenever standard mean is not provided, you can go with our same formulas. So same thing, mean of mean, that is X double bar, which will be required for center line of X chart, X bar chart. That is mean of all three values divided by n is 3 in this case. So you'll get it as 15.92, whether all of you are getting same or not. And again, control limits for that will be z, since standard deviation is directly provided. If not, we can use a2 value, a2 from the table which we will get it. So over here we can get it as 16.22. So after that we can draw the chart and you will get it as it is. I think you can draw this chart afterwards. You may have taken the snapshot. If not, you can take the snapshot of this slide so that whether you are getting the same type of chart or not, you can check it. And next method or alternative, we can use this table. As I told you, this table will be helpful if standard deviation is not provided in the numerical. So these are the only two difference or two cases we can say while solving the exam numericals related to R bar and X bar chart. One is the standard deviation example, another one will be directly using the chart. So when we'll use this, whenever the sigma variation is or distribution is not known, that time you will use this factor. So this was X bar chart. Now range maximum minus minimum will get it like this, and then you can get it R bar. And after getting R bar, central tendency value we have got it. So R bar and X bar chart in this fashion. So for drawing R bar and X bar, you will get this, and then you can draw the chart. Now this one is important. You can immediately take the snapshot and find out the values. Now over here, sample observations are not provided, but directly we have given the mean. That is sample mean we have provided, that is X bar. So simply mean of all these values will provide us the X double bar. So calculate the process capability. Now yet we are not discussed process capability, but no problem. We can solve the numerical again. So process capability will keep it aside for some time because we'll be discussing this topic in our next lecture or maybe of next topics. So show sigma and specified tolerance on a normal distribution curve. So for that we have to draw X bar and R bar chart again. So what is the given dimension? So specification of the item is provided, that is 500 plus or minus 5, that is tolerance, small n, that is sample, then capital N sample size, A2, D3, D4, that is instead of providing the table they have given the values, and then you have to plot the chart. Now I think, can you calculate this mean, and then we'll stop for today's lecture. If you have any doubt related to today's lecture, you can post it. We will solve few more numericals. So instead of solving, I will just show you one standard template for this. So same data, you can check it. I have plotted it in our template for getting the charts. Okay, you are getting value as 500.1 and R as 3.7. Okay, good. I will check it again. Again, few more answers. We'll check it whether you are getting same or not. So I have just substituted this over here. I think slide is visible. Okay. So for drawing X bar and R chart, I have one template. The same samples I have taken over here. You can increase it. If you have a number of more samples, you can add it over here. So what we want is we have to take the mean of this. So direct mean is taken over here. So you were posting few of the answers, I have got it. So same I think. Okay, 500.1. And the range is maximum minus minimum of this. So average of this, that is 3.7. Okay, good. And the factors, small n was I think 5.